Okay, ladies and gentlemen, we just got done talking about 7.4, which was just solving basic equations. Well, let's tag some stuff on top of that, which talks about 7.5, which is solving equations. And then you're probably saying, well, we already did that already. Well, no. What we did is we got to the point where we could already, where we knew how to think about when it was, say, a trig function equals 1/2 or 1 or √3/2. Well, what about when we still have to break it down to the point? Because reality, when I said solve, and oops, excuse me, when I said sine of, say, x is -1/2, right? That actually came somewhere, came from somewhere. And what do I mean by it came from somewhere? Well, let's say I said cosine of x equals 0. Well, good news is this came from a beginning equation. Like, so to get here, some work needed to happen to get here. And as a matter of fact, here's where it came from. Cosine of x plus cosine of x equals 0. So that means we have to factor this somehow to produce these pieces. It's not as hard as you think it may be. You just have to get used to what you are looking at. After all, just keep in mind that no, cosine of x and sine of x is just two blobs, kind of like how you would have a y or a z or a p. So we'll treat them in the same fashion. So let's start with this problem, and let me just clean my board real quick. So we have 2 sine of x cosine of x plus cosine of x equals 0. Well, let's see here. Let's change a little bit of color here. Maybe we can make it a little bit more obvious. As you can see here, cosine of x and cosine of x are the same thing. Okay, so what this means is that I can factor these two things out. So watch this. I'm going to pull out a cosine of x, which gives me 2 sine of x plus 1 equals 0. And doesn't this look very familiar? Kind of like when we were working with algebra. So good news, if I have two blobs multiplied together to equal 0, what does that mean? Well, either cosine of x equals 0 or 2 sine of that x angle has to equal 0. Now, this is how we would normally tackle it. And now isolate. Well, the cosine is already isolated for us, so we could think about him in a second. So I need to isolate for my sine. All right, we are there. Now, normally if this is algebra, we'd already be done. But this is not algebra. This has a little trigonometric twist. So now you got to think to yourself. Let's look at cosine of x. Cosine of x is equal to 0. Well, if you know your unit circle, cosine of x, the x's are 0 at the top and the bottom of your unit circle. So this is pi over 2. And 3 pi over 2. And remember, we're talking primary solutions. That means in the first revolution. So this means that x could possibly be pi over 2 or 3 pi over 2. Okay, that's just this one. We gotta look at the other one. Well, where is sine of x equal to -1/2? Well, a helping tool is to say, where is sine of x negative? Well, it's negative in 3 and 4. So that means 3 and 4 should produce two answers for me for where the sine, the y, is a negative. Well, where is the sign of negative? I think it's -1/2 here and here. I'm trying to draw the circle, but my circle is not coming out very well. And this is √3 over 2, -1/2. And this is √3 over 2, -1/2. Now, if you notice, I know my unit circle, so I know what points live there. So I know where the x is, the y is -1/2. So what angle is that? Take a second, think about it. What does x have to be? Pause the video, think about it, produce the answers, and then unpause the video and see if you're correct. Okay, so if you did this correctly, you should come up with 7 pi over 6 in the first revolution and 11 pi over 6. So that means your answer within the first 2 pi is pi over 2, 3 pi over 2, 7 pi over 6, and 11 pi over 6. Not too bad. It's pretty simple. To find the primary solutions is really easy. All you got to do is use all the algebraic solving tools you've had in the past, and you should be ready to rock and roll. Let's try another one. Okay. Now, one of the solving techniques we've used from the beginning of time is something called U substitution, right? Quadratic-ish. So find all primary solutions of this equation. sine squared x minus sine of x minus 2 equals 0. Now, I want you to take a look at this, guys. If this doesn't shout you substitution to you, I don't know what does. And let me rewrite it for you so I can make it a little bit more obvious. That's like saying this. So it's almost obvious that your u should be sine of x. So if u is sine of x, you end up with u squared minus u minus 2 equals 0. So you could factor this. Easy. Now don't forget we're solving for sine of x. So u sub problems is we're going to tackle it the exact same way. Alright, so now take a second and think to yourself, when is sine of x equal to 2? Correct answer, never. Why is it never equal to 2? Because sine, the biggest he can be is 1. Right? Think unit circle. The biggest he can be is at the top of the unit circle. That's 1. So this guy you get no solution from. Undefined. Okay, this guy, where is sine of x negative 1? Well, that's only one place that I can think of. Here's your unit circle, and that is right stinking here. That's 0 minus 1, which is 3 pi over 2. So you only get one answer from this one, okay? So these guys really aren't all that hard because all the things you're comparing to has to be less than 1. Otherwise, there's no solution to it, okay? Let's take a look at another juicier one. We're somewhere halfway through the video. I'm trying to make sure it runs too long. Well, if you notice, when we did identities, let me erase my slate. Same solution, find all solutions within 2 pi. I always gave you two massive things to always keep in mind when we did identities. I said make sure we were working with the same angle. Okay, so you can't have a twice angle somewhere and a 3 times angle and a single angle, meaning that the angles can't have a 2 in there. They all got to be the same angle. And more importantly, so make sure we have the same angle. That was the first big key. And the second one was we need the same trig function. And that's true. Okay, so if you look at this particular equation, we have sines and cosines. So I want you to think to yourself, when have we done anything with sines and cosines? Well, let's see. Well, I'm looking at this sine squared here, and I recall that sine squared x plus cosine squared x equals what, guys? That's right, 1. So if I were to solve for sine squared, I can change the equation by substitution. Notice that sine squared x is 1 minus cosine squared, as I've shown here. I could plug it into my equation. So what does that mean I end up with? I end up with 2 times, let's get some colorage in here, 1 minus cosine squared x, right? And then I can continue on with my equation, plus 3 cosine of x minus 3 equals 0. Now this really helps me a whole lot. And why it does it? Because now everything's in terms of cosine. When I get to that part where I need to factor, it'll be easier to do. I can't do it if they're sines and cosines. They're not the same thing, right? They're x's and y's. It doesn't make sense. So 2 minus 2 cosine squared x plus 3 cosine of x minus 3 equals 0. Let's simplify some stuff. This gives me a minus 1 plus 3 cosine of x minus 2 cosine of squared x, and that's equal to 0. Now, guys, I don't know about you, but it's already shouting u sub to me. I already see my u is probably going to be cosine of x because I have u squared, cosine squared x. But this negative coefficient in front is going to cause problems. Let me do my u sub first, and then I'll show you. So this is negative 2u squared plus 3u minus 1. It's hard to factor when that's negative. So what I'm going to do is I'm going to multiply through by negative 1. And then I'll make things a little better. Boom. Now, can we factor? I believe we can. 2u and u and minus 1 and minus 1. Double check. That is correct. Let's see if I can finish out the problem without making any boo-boos here. So I get u equals 1/2. U equals 1. And remember, we're not solving for u. We're solving for cosine of whatever angle x is. So this is cosine of x is 1, cosine of x is a half. Now let's think to ourselves, where's cosine x half? I'm not drawing the unit circle this time. Where's it going to be at? Well, I could think of two places that it's a half, and that is in the first quadrant, and that's at pi over 3. And the second place I'm thinking is in the fourth quadrant, but that's 5 pi over 3. Well, let's see. Cosine of x is 1. Where is that? Well, it's only in one spot. That's 0. Notice I didn't say 2 pi because 2 pi is the beginning of the next revolution or next time around the circle. So this answer is what we end up with. Bingo. Not very hard, guys. Not very hard. All right. So there's one more guy I want to talk about, and I was hoping you guys would stick around because this is a guy that has a double angle in it. Okay. So let's do one more with a double angle, and then we'll push on. So let me erase this guy, and we can rock and roll. All right. So check this guy. Find all solutions of this guy. Sine 2x minus square root of 3 cosine of x equals 0. So what's the first thing we need? We need the same angles. Do we have same angles? Point in fact is, do we have same angles? No, this is a double angle. Double angle is no good. In order for us to give this a single angle, we got to know our double angle formula. So you should know that sine of 2x is sine 2 sine x cosine x, which make things a lot easier. Now we have same things we can factor. So if you notice, we could pull a what out. Take a second, look at it. We have cosines of x's. And by having cosines of x's, we know that we can yank this out. And it leaves us 2 sine of x minus square root of 3. And it kind of turns into that first problem a little bit, doesn't it? So that's cosine of x equals 0. 2 sine of x minus root 3. I gravely dislike using examples with x. It should probably use theta from now on. This guy turns into sine of square root of 3 over 2. So now, back to the drawing board. Where's cosine of x equal to 0? Where's cosine 0? Well, that's only one spot I can think of. Or 2 as a matter of fact. And that's at pi over 2 and 3 pi over 2. If you don't believe me, draw your unit circle. Done and done. All right, that's my proof. Well, this one, let's see if you could do it by your head. Pause the video and see if you could tell me where sine of x is root 3 over 2. I messed up, guys. Sorry. Because after all, sine is positive here and here. And this is at pi over 3 and 2 pi over 3. I was actually getting that confused with sine inverse, which we'll cover in a little bit, but I just wanted to tell you why I made the boo-boo. All right, so x is going to be either pi over 3 or 2 pi over 3. Now, how do I know it's pi over 3? Because I know my unit circle. This is root 3 over 2, 1/2. This is 1/2 negative root 3 over 2. All right. That's all there is to it, guys. Get it the same angle, then get it as the same trig function, and then finally finish it off by factoring it, and then think about your unit circle. All right, guys. Signing off once again. In order to do anything or go somewhere you've never been, you got to be able to do something you've never done before. Next time when we talk, it will be about the same kind of thing, except we'll talk about what to do when we're keeping the double and triple angle formula. Soon.